Now we're going to do section 3.3. Section 3.3 is one of the most important sections in this course, and some students always complain that this is one of the more difficult or confusing section in the whole course. So I'll try to explain this the best I can, so please pay attention. So here's the idea. If you have, remember back in section, I think section 1.1, section 1.6 actually, it said that if f of x, let's say y equal to 3x minus 1, well, it's like f of x equal to 3x minus 1. This is a one-to-one function, because if you graph it, it's a straight line and passes the horizontal like this. So it has an inverse. Okay. How do I find the inverse? We said set it y equal to 3x minus 1, and then solve for this y in terms of x. So this is easy to do. We just add 1 to both sides. We get y plus 1 equal to 3x. Then we divide both sides by 3. You get y plus 1 over 3 equal to x. Then we change x to y, y to x. So y equal to, I'll change this x to y, equal to, I change this y to x. So I get this function. This is the inverse function. Okay, and that's easy process. One more time. Make sure your function is one-to-one, so it has inverse. Then set y equal to 3x minus 1, in this case, whatever it is, and then solve for x in terms of y. Change x to y, y to x, then you get your inverse function. Okay, we had this idea. Now the question is this: what if I have f of x equal to a to power x, the exponential function? This one is a one-to-one function from section 3.1. We discussed that. No matter what a is, this function is one-to-one. Okay, so it has an inverse. How do I find the inverse? I have to solve for x in terms of y. X equal to y. How do I solve for this x which is in the exponent? See, I cannot divide. If I had, well, first you have to say y equal to a to power x. You see, and then solve for x. But if I had y equal to a times x, this is easy because I divide by a, so x is equal to y over a. But this is not what I have here. You see, what I have is y equal to a to power x. So how do I solve for it? How do I solve for some unknown in the exponent? So that's the idea. In order to do this, we need a new device called the logarithm to do this for us. Okay, the logarithm is a tool that we're going to define what it is. It's a tool that helps us to solve for unknown when your unknown is in the exponent. Okay, so if I had that tool, I could solve for x in terms of y. Okay, and then I would change x to y, y to x. I would get my inverse function. Okay, now I explain this paragraph here, section 3.3. Just explained why we need this new device to find the inverse of exponential function. See, so if I have exponential function y equal to a to power x, it's then a one-to-one function. Therefore, it has an inverse function. The inverse of this function is a function that we would call it a logarithmic function with base a. Of course, the reason we call it base a is because the base of the exponential function is a. To find this inverse, we need a new device. A
this new device is this definition coming out, definition of logarithms that enables us to solve this equation for x in terms of y, and then later after we do that we change x to y, y to x, and then what we get is the inverse function for this exponential function. So let's see how this function is being defined. First of all, we start with base a, which is a positive number, not negative, not 0, and a equal to 1 will not produce anything interesting. So we eliminate case a equal to 1, and a has to be bigger than 0. If your variable x is a real number which is bigger than 0, this definition that we're going to do here is only valid for positive values of x, non-negative. I mean positive, bigger than 0, not even 0. So we define the logarithm of x to base a, or logarithm to base a of x, as the following. If I say y is equal to logarithm of x to base a, or y is equal to logarithm to base a of x, that means x is a to power y. So we are defining something new instead of something that we already know. Okay. One way to look at this is to I usually use this silly example here. If I say, for example, Bob is Joe's father. Okay. Then how can I write Joe by itself? If I say Joe equal to what? So how can I explain this relationship by writing Joe first? So Joe is Bob's son. So as you can see here, two different things, father and son, they define each other. So if you want to say Bob is Joe's father, is the same thing to say Bob is Joe's father, is the same thing to say Joe is Bob's son. Okay. It's the same thing here. You know, if I have y equal to log of x, so say y is equal to, think of log as father. Y is father of x, is the same thing to say x is son of y. You see, it depends upon which one you come first. X. So this is called exponential form. This is called logarithmic, and you can always jump from one to another one. Okay. They're translating something from English to Spanish, or something from Spanish to English. Okay. So if you want y by itself, everything else on the right side is x. Now if you want x by itself, you have to write it in exponential, so everything is on the right with instead of y. Now let's look at some of these examples here. Unfortunately, the copies I have is already written, and because I did this video and didn't have sound, so I have to do it again. Unfortunately, wasted my time. What is log of 16 to base 2? I say log of 16 to base 2 is 4 because 16 equal to 2 to what power? You see, if you write like what question mark equal to log of 16 to base 2, then question mark is playing the role of y, and x is 16 the role of x, and 2 is playing the role of x. So I put it in exponential form, so x, which is 16, equal to a, which is 2 to power question mark. So 16 equal to 2 to power question mark. So what number should question mark be? So that 2 to that power is 16, that's 4. So 2 to power 4 is 16. So log of 16 to base 2 is 4. Okay. The same thing here. If I have question mark, how much is log of 625 to base 5? I say it's 4 because if I translate this to exponential, I have 5 to power exponential is equal to 625, and with a little bit of play with the little bit with your calculator, you can see that 5 to the power 4 is 625. Therefore, question mark is equal to 4. I changed this problem here a little bit. What is log of 100 to base 10? Log of 100 to base 10. I didn't want to write 1 over 100. That's the particular case. Log of 100 to base 10. If you use this definition again, this means that this 10 base to this power of question mark must be 100. And we all know that 100 is 10 to the power 2. Therefore, question mark is equal to 2. So log of 100 to base 10 is equal. This one, log to a base a of 243 is equal to 5. What is a? Well, translate this to exponential. Say a to the power of 5 is equal to 243. So, and then if you use your calculator, 243 is actually 3 to the power 5. So as you can see, the exponents are equal to bases are equal to a is equal to 3. Okay. By the way, when I write log of something like that, this something here is called the argument. A logarithm without an argument doesn't make sense. If I say log of a, then it doesn't really make sense. Okay? Just like you say my, then you're always waiting for something to follow. My book, my money, my car. Okay? So my by itself actually is meaningless unless you follow my by some other means. Okay? So this is not log times x. Log of this whole thing is a number, and this is called the argument. So the logarithm has to have an argument. How about this one? I want to solve this for x. The first thing you do, convert to exponential. If I convert to exponential, so I say base 2 to power 3 is equal to the argument. So the argument x minus 1 is this base to this power. See, that's what I say. This base to this power is x. Or y is log of x to base a. So if you write that, see, I write it as 2 to power 3, this base to power 3 is equal to x minus 1. 2 to power 3 is 8. 8 is equal to x minus 1. If you add 1 to both sides, you get x equal to 9. One more example is a little bit more work involved is this one. First of all, from previous course, we have, if I have some number a to power p, the nth root, this is the same thing as a to power p divided by n. So whatever this power is, we divide by this n, we get rid of the radical sign. Okay? That's the formula we had in the diagram. So the first thing I do then, first I convert this to exponential. You see? So this 49 base to power x is equal to the argument. And then I change this argument here, this third root of 7, because 7 is 7 to power 1. If I use this formula here, it is going to be 7 to power 1/3. Okay. So that's what I have. Then 49 is 7 squared. 49 is 7 squared to power 7 to power 1/3, and then you multiply these two exponents and you get 7 to power 2x is equal to 1/3. Now the bases are equal, therefore exponents are equal. So 2x is equal to 1/3, therefore if you divide by 2 you get x equal to 1/6. Okay. You work this problem one more time for yourself to understand it. Now, there are two special cases of logarithms because this a, this base a, could be any number. You see, this a could be any number bigger than 0. So it could be 10, for example. 10 is, for obvious reason, 10 is a famous number, you know. And is also discussed. Remember we discussed natural base, exponential function, natural exponential function, e to power x, that e was important. So if I choose this a to be 10 or e, see, if you don't see any number here, it's 10. So if you don't see anything there, it's log of x, that means log of x to base 10. So if you convert it to exponential, then you say the argument x is equal to 10 to power 1. If I have ln simply says, you see, ln says log to base e. So log base e, we use this notation ln because it's so important. I use a special symbol for it. So ln always means log to base e. Okay. So if I have y equal to ln of x, or natural log, we call it the natural log because I'm using e. This is called common log because we're using 10. Then exponential is going to be e to power 1. These two functions are, these two logarithms are built in every calculator, even scientific calculators. You can compute them. For example, if you want to compute these numbers, as I said, I have already computed this, so I'm going to do it one more time. Like if you want to know what log of 29 is, see, let's make this one bigger. You see here, if you look at your calculator, you see log. That's common log base 10. So if you want to do log base 10, 29, simply say log 29. You get 1.46. Approximately, not 1.46. Now if you want to do, I changed this problem, you know, because it was similar number. I changed it to log of 73. What is that? Log of 73, again we say this is natural log. There is no number here, that means base 10. So say log of 73. There you go, 1.86. Now if you do, let's say ln of 3/4. How did I get this one? ln of 3/4. Well, not ln, common log. Common log of 3 divided by 4. Negative 0.1249. So if you round it up, 0.125. Finally, if you want to do ln of 37, or common natural log, for natural log you use ln right here. So I say ln of 37. Now if I do another one, let's say ln of 2163, what is that? ln of 2163. 7.68. Very easy to use. Now the question is, what if I have anything other than base e, AE or 10? Can I use my calculator? See, basically what I'm saying is this. what if I have, if I want to compute something, let's say, what is log of 137 to go to base 6? What is that equal? Okay. How would I do that? Well, there are two ways to do it. If you have a new calculator, you actually can do it with your calculator directly. Okay, and that's what basically I have. You see, so if you want to do it directly with your calculator, if you don't, there is a feature in your calculator that allows you to do this. But if you don't have that feature, then there is another way to do it that I'll show you in a minute. So basically, you see, go to math. You see math here. So go to math and get this menu. Then go down the list. 1, 2, 3, 4, 5, 6, 7, 8. And if you go down after 8, you have 9, and then I don't have a number. It says summation. Summation, I don't have anything to do with that. And then if you go down one more, you see it says log base. This calculator has log to base into any base. So if I want to use that, if I want to compute log 137 to base 6, how would I do it? I choose this, I say enter, you see, log base, and my base is 6, 137. Then I say enter. That's my answer. 2.745. But if you want to do log, let's say 293 to base 11, how would you do that? Go to math, go all the way down to log base. Log base by base is 11. So I get 2.37. We'll do one more. Let's say you want to do log of 198 to base 8. How would I do that? Base 8, the number is 198. Say enter 2.54. Okay. Now what if you don't have this feature in your calculator? Actually, you can do it another way, but is discussed in section 3.3. So what I'm gonna show you, I'm gonna get this section 3.3 here, just a second, and 3.4, I'm sorry. 3.4, right here. This part of 3.4, this part, I'll move it to section 3.3. Okay, so I'm going to discuss this in 3.3. This is the formula here, helps you to do any other base other than E or 10 if you don't have that feature in your house. Okay. So what does it say? It says, basically it says the following. It says the following. If you have log x to base a, you want to change your base a to another base b, let's say. that's okay, just say log of x to base b, but divided by this log of a to base, log of the old base to the base of the new base. In particular, because I want to use my calculator, I choose the speed to be 10 or e. So log of x to base a is a common log of x divided by common log of a, or natural log of x divided by natural log of a. Okay. So this is a very handy thing to use. For example, if you want to use, let me just do these both techniques here. For example, if you want to do log of 23 to base 2, how would I do that? If I'm going to use these formulas, I simply say log of 23 divided by log of 2, or natural log. Okay, natural log of 23 divided by natural log of 2, and if I do that, natural log of 23 divided by the natural log of 2, get 4.53. So let me make this one bigger a little bit. Log of 23 divided by log of. Now if I use this one using the other technique, the other feature, so I go to math, log base is 2, 23, I get the same number, you see. So if you have that feature in your calculator, just do it directly. If you don't, then use this formula here. But if you want to do log of 367 to base 5, how would you do that? I would write it as ln of 367 divided by ln of 5. Now I can use my calculator, so let me do it here. ln of 367 divided by ln of 5. 367, yeah. I get 3.669. Now if I do it with the other technique, go to math, use this base. Base is 5, and the number is 367. You see, I get the same number. So if you have that feature of your calculator, fine. If you don't, it's not the end of the world. You can use it. So let's do a couple more here. Log of 16 to base 1/3. Okay. So you say, let's do it both technique. Log of 16 divided by log of 1/3. 1 divided by 3. See, you get negative 2.53. Now if you use that feature, your calculator, if you have it, math, log base, 1 divided by 3 is the base, and 16 is the argument, you get the same number. And finally, one more. If you want to do this one, this is actually ln of 16 divided by ln of 0.53. If I use my calculator, ln of 16 divided by ln of 0.53. So I have negative 4.367 by this technique. Now if I use that other feature, point 0.53 is the base and 16 is the argument. You see, you get the same number, negative 4.367. Okay. So, but the rest of section 3.4 come back to it later on when it's time. I'm not going to discuss that later. I just did it for this. I should have included this part in section 3.3, but I didn't. But I might do it later for the future. But hopefully you don't need it. So we discuss section the section later on. Okay. So this is section. Okay. The next example. Is an example that helps you to transfer between or jump between exponential and logarithmic. Okay, like if you have logarithmic exponential, you want to write the same thing in logarithmic. If you have logarithmic, you want to write it in exponential. Okay, so. Okay, let's do this one more time. This example is an example, has of course 6 bars, that shows you how to go from exponential to the logarithmic, or vice versa from logarithmic. Of course, the key to this. The solution is the definition, the main definition we have. If you have logarithmic, you can write exponential. If you have exponential, you can write logarithmic. Depending upon whether you want this power to come first or this one. But this one we have t minus 1 equal to a to the power x squared plus 3. To write this in logarithmic, this exponential should be equal to this base to the power of t minus 1. The point is that which one of these two guys come first. Now this one has come first here. Now if I want this one to come first, then I use logarithm log of a. Like b, 81 is coming first now. I want 4 come first. So I say 4 is equal to log of 81 to base 3. Okay. So the base, always write log of whatever this number is to base 3 to get this exponent. And here, we say this exponent is equal to log of x plus 2 to base 7. And here, we're going to convert to exponential. So you say, if I raise this base here 10 to power 4, I should get 10,000. So 10,000 equal to 10 to power 4. And here, you say this 4 to this power is equal to x plus 5. You are using, again, you have to just figure out what plays the role of x and what plays the role of y. Like here, I'm logarithmic x plus 5 plays the role of x, and square root of y minus c plays the role of y, and of course your a is 4. So if I rewrite it in terms of x equal to a to the power y, this is what I get. The argument is equal to this base to this power. Finally, because you have natural logs, this means you have log base t. This is base t there. So it's going to be e to the power x plus 5 is equal to this. Now that we work so hard to figure out what logarithm is in relation with exponential, we work really hard to understand how to transfer between logarithmic and exponential form. Now we can define our new function. Our new function is called the logarithmic function, the basic logarithmic function, because we have only one x in our argument. F of x equals to log of x to base a is called the basic logarithmic function. Okay.
at some examples. Let's say I have this function f of x equal to log of x to base 3, g of x log of x to base 5. Okay, a logarithmic function, one base 3, one base 5. How do I find f of 81? F of 81 simply says logarithm of 81 to base 3. Now I can use my calculator to do this, and this is going to be equal to 4, because 3 to power 4 is 81. You can actually do this in your calculator using that base thing. You see, if I go to math, go down the list, log base is 3, 81, log of or g of 1 over 125. This is your g, so this is actually logarithm of 1 over 125 to base 5. Okay. If I use my calculator again, say math, log base 5, 1 divided by 1, 1 divided by 125, negative 3. So the answer is negative 3. So this is it. Example. Let your function f of x to be L or g of x, common log of x, and g of x to be natural log of x. Use a graphing calculator to evaluate the functions for x equal to 13 and x equal to, we did this, really, this is not anything new. So if x is, so f of 13, what is f of 13? F of 13 is common log of 13. See, this base is 10. So if I do that, log of 13, and that's 1.113. 1.113. If you do f of 32.86, what is that equal to? This is what becomes common log of 32.86, and what is that? If I put it in my calculator, common log of, clear everything, common log of 32.86, so I get 1.516, 1.517 if I round it up. And you can do ln of the same thing. You see, g of 13 is ln of 13. If I do this ln of 13, you know how to do it. So let me see, ln of 13 is 2.565. 2.565, and g of 32.86 is equal to log of 32.86. I'm sorry, ln, not log, natural. have almost 3.5 if you round it up. Okay, so I would say you do this one as an exercise for you. Okay. Well, actually, I can do it. You see, maybe I should do it really. Let me do it. You see, as I said, you see, use the method of finding the inverse function and definition 1 to show that y equal to log of x and y equal to a to power x are inverse of each other. Okay, so let me start with f of x. You see, let's say f of x equal to a to power x. This is 1 to 1. So as inverse. So how do I find the inverse? I say y equal to a to power x. I replace, and then I solve for x in terms of y, x in terms of pi. X is L logarithm of y to base a. You see, now I change x to y and y to x, and that's the inverse function. So as you can see, this function here and these functions are inverse of each other. So if you have exponential, then logarithmic function is the inverse. Now let me start with the inverse. You see, with the logarithmic. So I say y equal to, or f of x. Let's say f of x equal to log of x to base a. So I want to find the inverse of this function because this is 1 to 1. So y equal to log of x to base a. Then to solve for x in terms of y, you have to use it in exponential. So x is equal to y to power a. By definition 1, that key to that locked door, as I said. Now change x to y and y to, a to power y. Sorry about this. Let me erase this. X is equal to this base a. A to power y. Now change y to x, x to y. You have change this x to y equal to a. That changes y to x. See, and this is the inverse function. So this function and this function are inverses of each other. Okay. So if you have exponential, logarithmic is the inverse. If you have logarithmic, exponential is the inverse. Okay. So I thought I would do this example for you, so you can follow. You can finish next example. This exercise. Next example. This example right now is very easy. If f of x is 2 to the power x, what is the inverse? Well, is log of x to base 2. If f of x is log of x to base 4, what is the inverse? 4 to power x. What is the inverse of this function? Again, maybe I didn't move my paper. You see, let me change this slide. There we go. If you have 2 to power x, what is the inverse? Log of x to base 2. If you have log of x to base 4, what is the inverse of that? 4 to power x. What is the inverse of this one? Log of x to base 1.75. What is the inverse of this one? E to power x. Every time I have ln, it translates to e. If you have base 10, it's the common log. So this is going to be ln log base 10, we don't write it, of x. And if you have log, then this is going to be 10 to power x. Okay. So these are